Okay, welcome back to another Physical Sciences 3 lecture. We are on velocity versus time graphs at the moment, and we're going through the next example. So in this example we have an object which moves for 20 seconds as shown below, 12 seconds as shown below. Oh, got my colour wrong again. Let me get that colour next. Okay, 12 seconds as shown in this velocity versus time graph. Okay, and we have a constant time here and it's increasing, so it's accelerating here and it's decelerating, or it's accelerating south, and then it's constant again down the bottom here. We'll have a look at it. So the first thing they ask us to do is find the object's velocity at time 3 seconds. Okay, so 3 seconds is here, and the velocity is 3 meters per second north. Let's say v equals that. Okay, at 10 seconds, it's down here, and it's going 6 meters per second south. Oops, writing north, said south, writing north. So v equals 6 meters per second south. And in case that confuses you, it's negative 6 meters per second north. Okay, so down here is south, and up here is north. All right. So calculate the acceleration at 2 seconds. Okay. At 5 seconds and 8 seconds, well, 2 seconds is here, and it's a flat line, so the acceleration is equal to, it's always equal to change in v over change in t, which equals 0 meters per second squared. Okay, at 5 seconds it is here, it's along there, and so we need to calculate the rise over the run. So this is the rise here. The rise, it goes from 3 to 6. And so acceleration equals 3 to 6, so it's positive 3, and it goes from, the run is along this way, so it's from 4 to 6, so it's 2. So acceleration equals 3 over 2, which is equal to 1.5 meters per second squared, and it's north. It's positive. Okay, at 8 seconds, it's all the way along this line here. So we again have rise over run. So this is the rise here, and this is the run along there. So this rise goes from 6 down to 0, so the rise is equal to minus 6, and the run is equal to 2. Okay, so then the acceleration equals negative 6 over 2, which is equal to negative 3.0 meters per second squared north, which of course equals 3.0 meters per second squared south, in the positive. Okay. Calculate the displacement after 6 seconds and 12 seconds. Alright, so here is 6 seconds along here, so I'm going to draw, we need the area under the curve up to that point. To there. And we need to break it up into rectangles and triangles. So, just getting my ruler. Going across there like that. Oops. Okay. So we've got this rectangle here and this triangle in here. So that's my triangle. So the total displacement up to 6 seconds is going to be, let's see, this rectangle goes from 0 to 6 and it goes up 3. So S is equal to 6 times 3 plus the triangle goes for 2, so the base is 2 and the height is 3, like we said before. So half times 2 times 3. So it's 18 plus 3 is 21 meters north. Okay, at 12 seconds, so we've already calculated everything up to 6 seconds. Now we need to calculate this one, the triangle in here. Okay, I think I've overdone that. That's enough. And then we have also, I'm not using my ruler, I'm just trying to try and do as straight a line as possible. So we have this rectangle here, and also this triangle in there as well. All right, so we're going to have S equals 21. So that's this bit here, 21 meters north. So it's up to 6 seconds. And then we're going to add on this triangle, which is a half times 2 times 6. So it goes up 6. Okay, so now we need to add on the next bits. So we get this triangle here. It is, again, 2 across, so that's 2, but it goes -6. So the height is actually a -6. So plus a half times 2 times -6. And then the rectangle, okay, similarly, it's got a length of 2, and then the width of -6. So plus 2 times -6. So what we get is 21 plus 6, which is 27, plus -6, plus -12, so minus 18 for that negative bit, which is equal to 9 meters. And because it's positive, it'll be north, 9 meters north. All right, so now we can calculate the average velocity for the first 6 seconds. So V, the average velocity, is equal to S over T, which equals 21 over 6. And 21 over 6 is equal to 3.5 meters per second, and that is north. For 12 seconds, VAV is equal to, this time is 9 meters over 12 seconds, so, and that is equal to 0.75 meters per second north. Okay, so that's the average velocity for the whole 12 seconds. Okay, next we have to find the distance travelled. Okay, so we find the distance travelled in the same way. So remember, distance and displacement have the same units of meters. So it's easy if it's all positive. So we get 27 meters up to this point here, up to 8 seconds, which is shown here. So 27, that's up to 8 meters. And then we start heading south, and we end up going 18 meters south. But remember that distance doesn't care what the direction is. It's just absolute numbers. So in total, we've travelled 27 plus 18 for 45 meters. So I'll just write that in here. Distance equals 27 plus 18, which is equal to 45 meters. And then we can calculate the speed, which is equal to distance over time, which equals 45 meters divided by 12 seconds. And that comes out as 45 divided by 12, 3.75 meters per second. And we don't care what direction, because it's distance, because it's speed. So that's the average speed over that time. Okay, so we'll leave the next example for another video.